you can actually take a whole class on trigonometry. Trigonometry. Any idea what that word means?
Triangle geometry.
Kinda. Yeah, so this is the study of the measures of the angles in triangles. So again, I abbreviate a lot, so if you get confused about what the abbreviations are, just give a holler, okay?
What's the highest math class you can go?
In here,
Like anywhere, like in college and.
well, you can take several classes of calculus, and then it's like differential equations and linear algebra, finite math. Those are all pretty high. Pretty high.
The highest here is calculus.
The highest here is calculus. So what this is going to lead to is what Mr. Knipe said, are trigonometric, that's just a fun word to say, ratios.
Does it have an abbreviation?
No. So what's a ratio? A fraction, right? So today we're going to make fractions. All right? We're going to make fractions. So when we talk about trigonometric ratios, you're going to, you can only do this, or these, with a right triangle. So if you do not have a right triangle, you cannot use trigonometry. And you're never using the 90-degree angle. So how do I know which one's the 90-degree angle? It's got the little box or the square, exactly right. So again, let's draw some kind of right triangle. Put our box in there. For argument's sake, let's put A up here, B down here, and C here. Okay, remember always that my angles are always going to be capital letters, and my sides that go with those are always going to be lowercase letters, right? So again, we said that they kind of go together, but you don't really need the lowercase letters today. All right? So we could do the trigonometric ratios in this particular triangle from either angle A or angle B. We can never do it from angle C, or whatever it happens to be that they call the right angle. Good with that? All right. So then the next thing that we need to talk about is we're going to look again at one of those acute angles, but we need to know words like hypotenuse. What do you know about hypotenuse?
Cross.
Okay, so it's the longest side, and it's, as you said, across or diagonal, however you want to say it, and it clicks in your mind, from what?
The right.
From my 90-degree angle, or the box, okay? And again now, that 90-degree angle, what's true about that angle in a right triangle? It's always the what angle? It's always the biggest angle. So doesn't that make sense? If this is the biggest side, because it's the hypotenuse, this has to be the biggest angle, because remember when I told you they went together? So if it's the biggest angle, it should be the longest side. If it's the shortest angle, or smallest angle, it should be the smallest side. That makes sense? Okay, so the first word is hypotenuse. We've talked about that more than once, so hopefully that's not too bad. The next word that we're going to talk about, we've already talked about this one too, is opposite. What's opposite mean to us in this case? Either across from or diagonal from, however, again, your brain works. And we're talking about opposite, the opposite side from the angle that is given. And the angle that is given, they'll tell you. So they'll say, either do this from angle A or from angle B. If they tell you to try to do the trigonometric ratios from angle C, you just say, I can't do it. Anytime that they ask you to use the right angle. All right, so hypotenuse, opposite, and my last one, probably a new word to you. What's that word? Adjacent. What's adjacent mean? Perfect. Or next to. Okay? So, here's where we got to clarify things. When you look at an angle, how many sides would be right next to that angle? 2 always, right? If this angle, if I'm talking about angle B right here, and I put an arc right there, I'm talking about that angle B. Everybody see that there's a side here and there's a side here? Okay? So when you're talking about adjacent, you're talking about adjacent from the angle that we're talking to. But, big star, cannot be hypotenuse. If hypotenuse is hypotenuse, it has to be hypotenuse. So, with respect to B, see how next to, this side right here is next to it, but so is this side over here is next to it, but this side, AB, is my hypotenuse, so it has to be hypotenuse, it cannot be adjacent. That makes sense? So, if it's hypotenuse, it has to be hypotenuse, you cannot call it adjacent. So we're talking about with respect to either A or B. What side is adjacent to angle B? That side right there is adjacent to angle B. Okay? Yes, this one also is adjacent to it, but it is hypotenuse. So if it is hypotenuse, it has to be hypotenuse. It can't be called adjacent.
Oh.
Okay? That makes sense now?
Yep.
All right. So now, we're going to build trigonometric ratios. So we're going to build fractions. So there's going to be numbers given to us. We're going to use those numbers around there. And by whatever ratio they tell us, we're going to build that fraction. All right? So there's 3 main trigonometric ratios. 3 ratios. This is where if you got a calculator, get your calculator out. And as Mr. Knipe already said, my 3 ratios are what?
Sine, cosine, and tangent.
Okay, so the first one is sine. It's actually spelled with an E. But if you notice on your calculator, it's just what? It looks like sin. Please don't say sin. It's a sin to call sine sin.
Mine has a sign with -1.
Okay, we'll talk about that later. Okay, so we have sine. Number 2, we have, what'd you say?
Cosine.
Cosine. And this is actually how you spell cosine. But on your calculator, it's COS, right? And then last is what?
Tangent.
Tang what?
Yeah.
How about we call it tangent? Okay? So again, here's my tangent. How to spell the word tangent, but on your calculator, they just use tan.
They're right next to each other.
Okay? So, here's the thing. This is what you gotta make sure that you convince yourself. Because a lot of my kids in geometry, they had a hard time with this. So put a star here. The degree measure of the angle always goes with the word. And the word are my 3 ratios, sine, cosine, and tangent. Okay? So, whenever they give us the sine, they could either do it in two ways. They could say sine of A. Notice my angle it should be a degree measure, so I could write it as the sine of A. Or I could say find the cosine of 37 degrees. So see how a degree measure is always with the word? So it could be a capital letter, or it could be an actual degree measure, because both of those signify an angle. So the angle always goes with the word. Alright? So, question.
Why is cos when it's negative, like it has a negative thing by it, not me?
Now what?
Like when it has a negative one by it, it's 90.
Yes. That's ahead of us. Don't think about that right now.
Right angle.
Okay? I like the question, just that's ahead of where we're at. Okay? So, how are we going to remember? So, basically, what we're going to say is we want to find a fraction that represents the sine of A. Alright, so with the sine of A, we would have something and we're going to set up a fraction. And in that fraction now is using these words that we introduced: hypotenuse, opposite, and adjacent. Okay, so how do I remember this? And you're going to like this because it's weird. You're going to remember this by remembering this funky word right here. So, Toa. Alright? So, anytime from here on out that you hear SOHCAHTOA, boom, trigonometry should come into your head. Alright? A lot of people don't know how to do some of this stuff, but I guarantee you ask them about SOHCAHTOA and it'll just say, oh yeah, that's what you do triangles, or right triangles with. Okay? So, look at this now. We're going to use this word to cheat. Notice my capital letters are my three ratios. Capital S is my sine, capital C is cosine, capital T is tangent. Sine, cosine, and tangent. Okay? The little letters, or lowercase letters, are going to tell you the sides used in your fraction. So what do you think little o and little h mean? What do you think little o means? Opposite. Remember these words that we introduced? We're going to use those same things. So, when we talk about sine of A or any letter, we are going to make a fraction that is opposite. What do you think the H means? Hypotenuse. So we're going to have H on the bottom. Okay? So, what do we use for cosine? What does A mean? Perfect. Adjacent. Over. What's H again? Hypotenuse. And then finally tangent. Opposite.
Over adjacent.
Perfect. So, SOHCAHTOA. Gotta remember the most important part of SOHCAHTOA. You're all gonna remember it tomorrow. Trust me. I'm gonna ask you what that funky word was, and you're gonna say SOHCAHTOA. The most important part of SOHCAHTOA? Spelling it right. Okay? If I don't know how to spell it, it's meaningless because it doesn't tell me the right thing then. Know what I'm saying? Okay? So, how do I use this? Well, let's put our triangle up again. Let's put C down here, A up here, and B down here. Okay? And we're going to try to find the sine of A, the cosine of A, and the tangent of A. So again, I could either pick A or B. I just picked A. It's no big deal. Alright? Then gonna give you numbers around the outside of your triangle. So basically, let's put 4 here. Let's put 6 here. And what would this number have to be if this is 4 and this is 6?
10.
Why? How can I figure this out?
X squared plus B squared.
Pythagorean theorem.
Pythagorean theorem. So what's 4 squared?
16.
What's 6 squared? What's 16 plus 36?
52.
52. So we don't want to do that one. We want to have a,
2.
hang on. I gotta just think of something.
Oh, dude.
Nah, should work.
I would say
25 plus 144 is what? 169. Okay, so these 3 should work. All right. So here we go. Where are we coming from? Look at the angle that they give us. So we are looking at angle A for all 3 of these fractions. All right. Angle A. We would first want to find the sine of A. So from A, we're going to set up a fraction by using our letters. So what's opposite of A? What number is opposite of A? 5. So the sine of A equals 5 over what is the hypotenuse in our triangle? 13. So when they say what is the sine of A? 5 over 13 is my answer. I'm going to write a fraction. Okay? They might ask you to write this, though, as a fraction and a decimal. So when you are asked to find the decimal of this, simply just punch in this into your calculator. Do not punch sine, cosine, or tangent. You're just punching 5 divided by 13 into your calculator. What do you get?
0.4.
That's it? Huh?
Oh, you want the entire thing?
Yep.
Oh, it's 0.3846.
Do it again to 4 decimal places.
0.3846.
Okay? So does everybody understand how they got that? You simply punch in 5 divided by 13 in your calculator. Okay? So, what is cosine of A? So again, I'm starting at A. Now here's where it gets challenged. Cosine is what? So what is next to A but not hypotenuse? Right. This way, right? So we have 12 over what? 13. Perfect. So punch it into your calculator. 0.923 what? 0. Okay. And then finally tangent of A. What is opposite of A? 5. What is adjacent to A? 12. Perfect. So my answer is
4.466.
so if we're rounding to 4 decimal places, we would say 0.4167. Right? Because I'm rounding to 4 decimal places. So what do you think?
So all 3 of those are.
So yes, these problems right here are going to be worth a lot. You need to answer it as a fraction and as a decimal. Every single time. Okay, so with the same triangle now, with the exact same triangle, I want you to find the trigonometric ratios from B now. Okay, so from B, I'm going to do sine, cosine, and tangent the exact same way. But now I'm concentrating on angle B. How do we do? So again, we're just making a fraction, and then whatever fraction you come up with, you punch those two numbers into your calculator. You do not use any of the buttons on your calculator yet. So again, the most important thing is kind of telling yourself, what angle am I working from? Everybody get their answers? All right. Just one person, raise your hand here. Sine of B. Who's going to tell me? Jacob.
12, 13.
Opposite over hypotenuse. Everybody agree? So, what's my decimal answer?
0.9230.
Say it again.
0.9230. Oh.
Remember, we're rounding to 4 decimal places. Okay? Cosine of B. Who's got that answer? Grace. 5 over 13. How'd you do? Fraction? Answer? Decimal answer. 846. And tangent. How much?
12 over 5.
12 over 5 or
2.4.
2.4. How do we do? What do you think? Want to do another one? Eight, 15, and 17. And let's call it MNP this time. All right, so if I ask you to find from P, okay, from P. So again, can I do this from M? No, because why? It's the right angle. I can never do this from the right angle. Because opposite and hypotenuse would be the same thing from M, right? So what do we say? P, right? So again, I would highly recommend you writing out these triangles and showing yourself, what are we doing this from? So again, make sure when you do this on your assignment, I don't think they tell you to do this, but every single time that you do this on your, if they ask you to find the 3 trigonometric ratios, I want you to write them as fractions and as decimals. Okay, so you get used to it for geometry. How do we do? Ready? Sine of P, what'd you come up with? 8 over 17. Agreed?
Yeah.
Cosine of P.
15, 17.
Awesome. So again, remember, P is next to, we have both next to's, but hypotenuse has to be hypotenuse. And then finally, tangent. 8 over 15, right? Opposite over adjacent. So what'd you get for 8 over 17?
44706.
Okay. 15 over 17?
0.8824.
Perfect. And 8 over 15?
5.5333.
Oh, I got that.
5,
No, wait, 5, 3, 3.
5, 3 repeating.
With 3.
So again, if it's repeating and they ask you to round to 4 decimal places, then just put 4 decimal places.
Would you round the last 3 to 4?
Does,
No,
do I round the
no,
last 3 to
never
4?
mind.
You should have just answered your own question,
I did.
right? All right, how do we do? Make sense?
Yeah.
All right, so it's no fun if we don't get to use a calculator, right? So when do we get to use the calculator with the buttons? All right, so anytime, again now, what should go with the words? The angles should go with the words, right? Well, in these, right here, they didn't actually give us measures of the angles. They just gave us the angle, right? So when do I get to use my calculator?
We find those.
You get to use your, well, okay, yeah, you do get to use your calculator a little bit on these, but to use the buttons on your calculator, and when I say it this way, I know it kind of sounds weird because, yeah, I use buttons in the last part, but when I say use the buttons, I'm still talking about my sine button, my cosine button, and my tangent button. Those are the 3 buttons that I'm talking about. You're going to do this only when they give you a degree measure. So if they tell you what one of the angles is, okay, so in an example, they might say that find the sine of 47 degrees. See how the angle is with the word? That tells you I can punch it into my calculator. So here's really, really important stuff about your calculator right now. Make sure everybody looks here. If you got a calculator somewhat like this, look down on either the very bottom or the very top of your screen, and you should see a DEG, or just a D. Make sure your calculator has that because it's in degrees. If it doesn't have that, we'll look for it in just a second. Does anybody not have? It might say RAD or a capital R. We don't want that. Those are radians. That's when you would get into pre-calc and stuff. Okay? Everybody in degrees?
Yeah.
But what's the M3 one?
What is the what?
M3.
M3.
I'm the answer.
I lost it.
So, those of you that have degrees already, just punch in sine 47 into your calculator, and you should get your answer.
We put the 1 on first, right?
No. Well, let me see what your calculator looks like. That's why we're doing this right now.
Yeah, but mine is the number.
Yes, you have to put your number in first.
Would you get, did you get 0.731353702? Did you put the number?
I don't know, but you're gonna have to, yeah, the directions somewhere.
I don't know.
I'll have to look at it a little longer. Well, no, because this has to say degrees. So I would guess you have to hit mode and then be able to change that mode. But I just don't know where it is in there. Alright, what do we get?
Point
Point
731.
7314.
7314. So look, my answer is a lot like what we just had over here with my decimals, right? So essentially, you're doing the exact same thing, but over here I found sine of b by making a fraction and getting my decimal. Over here, I just used the actual degree measure in replace of that capital letter, but we still got a decimal answer. So essentially, it's the exact same thing. It's just a different version of doing it.
Hey, I got it.
Okay? So,
DEG.
DEG.
Yep, got it.
Okay, now punch this into your calculator. Sine of 47.
So can you do that like with the cosine?
So then you can do that with the cosine and the tangent also. So, next one, try cosine of 19 degrees. What'd you come up?
0.9455.
Perfect. Tangent of 76 degrees. 76 degrees. 4.010. Or 4.0108. Exactly right. Okay? Questions here? All right. What we're going to do now